In this exciting video, we're about to reveal the very first official images of OpenAI's groundbreaking physical robot. Artificial intelligence is advancing rapidly, and now many AI companies are taking a huge step forward by giving AI a tangible presence in the form of a real robot. OpenAI is backing a company named 1X Technologies, which is successfully bringing this concept to life. The robot they've developed is called Neo. Neo isn't just any robot. It's designed to be safe, well-balanced, intelligent, and will serve as your highly capable Android assistant. Before we dive into the recent groundbreaking developments that were unveiled last month, let's take a moment to explore the partnership between OpenAI and 1X Technologies. OpenAI made a strategic investment in this engineering and robotics company based in Norway back in March 2020. Through a funding round, they raised a significant $23.5 million to support 1X Technologies' vision. This investment was focused on establishing a production line in Dallas, Texas, and bringing their robot creations to a commercial scale. The star of the show, set to make its debut this summer, is Neo, a humanoid robot with 2 legs named after its bipedal nature. On their website, Neo is described as embodied artificial intelligence. 1X Technologies is pioneering the fusion of robotics and AI in an extraordinary way. Neo is essentially an android designed to imitate human behavior and capabilities. As it navigates its environment, it evolves, growing more intelligent and adept, achieving strength, gentleness, and adaptability that parallels our own capabilities. As Neo collaborates with you, it learns to adapt to various tasks and scenarios. Let's take a look into the remarkable features of one of the world's pioneering AI robots that promises innovation across the board. It all begins with a paramount focus on safety. Each Neo unit undergoes real-world trials before deployment. Neo's design, inspired by organic mechanics, ensures safety from within, making it well-suited for any environment. The safety-first emphasis suggests that these robots have no sharp edges that might cause harm if an accident occurs. Rigorous testing likely ensures that even in scenarios where Neo collides with people or objects, the impact won't result in significant damage. Now onto the smart behavior facet. Neo embodies artificial intelligence, uniting well-designed bodies with advanced AI capabilities. This enables natural conversations with Neo, and it can execute requests seamlessly. Here's where things get especially fascinating. Smart behavior pushes robots into a realm beyond conventional capabilities. Given that OpenAI supports 1X Robotics and their AI initiatives, it's reasonable to assume that Neo will incorporate an advanced AI mind, possibly a refined version of GPT-4. This tailored AI could facilitate more natural interactions, addressing a common challenge of delayed responses that often make AI exchanges feel less human-like. The choice of AI model could potentially be exclusive to Neo, ensuring swift, real-time interactions. This selection might involve GPT-4, a custom-built version for 1X Robotics, or even an upcoming large language model combining multimodal features, considering Neo's potential for everyday assistance, which may involve visual perception. Moving on, there's the aspect of balanced performance. Neo's movement mimics ours, enabling it to meet various needs. 1X's engineers have meticulously crafted Neo for precise, gentle movements with arms and legs modeled after human muscle dynamics. This means Neo can navigate doorways, ascend stairs, and perform tasks more naturally. This takes us to an intriguing point. While robots like the Tesla bot have demonstrated movement, Neo sets itself apart by aiming for a smoother and more human-like gait. This innovation prompts curiosity regarding how Neo's walking mechanics will compare to the capabilities of other advanced robots like those from Agility Robotics, Tesla, and Boston Dynamics. Moving along through the images, we can spot Neo within a household environment, engaged in what appears to be a cleaning task. This visual suggests that Neo's capabilities extend effectively to household chores. This isn't the first time we've witnessed this prowess from the company that previously demonstrated their capacity to create robots proficient in such tasks. One of their earlier models, showcased in a video about 2 years ago, features a robot named Eve baking cookies. The remarkable aspect is its ability to deftly handle tasks like gripping items, retrieving objects from the fridge, a feat that seemed more fitting for science fiction until now. It's intriguing to consider the advancements Neo brings compared to the previous generation model we're currently observing on screen. Shifting our attention to the most captivating facet of Neo's introduction, the description under the section Meet Neo provides insights into its control mechanisms. Here, we encounter a reference to the Control tab, where Neo's operation is linked to VR Teleapp Sync mode. If you're unfamiliar with this concept, VR Teleapp entails employing virtual reality technology to remotely direct robots or devices in a different location. This immersive approach enables users to interact as if they were physically present. A comparison to the movie Pacific Rim, where robot control mirrors the user's movements, or the demonstration featuring virtual reality guiding a physical robot, clarifies the concept. The presence of VR teleop sync mode raises questions about whether this will be the primary control method for Neo. This consideration becomes intriguing given Neo's incorporation of advanced language models and increasingly potent visual systems. Could it be a feature that allows users to intermittently control the robot from a distance? Picture this: you've left Neo at home and wish to remotely explore your surroundings. Could VR teleop sync mode facilitate this? An interesting prospect indeed. Subsequently, within the description's progression, we encounter Neo's ability to learn from tasks accomplished through VR teleop. This process involves users completing actions in a virtual environment, which Neo then mimics using its mechanical hands. Moreover, Neo's autonomy is highlighted. An autonomous system operates independently without human intervention. It possesses decision-making abilities, analyzing its surroundings and making choices based on predefined rules. Adaptability is key, enabling autonomous systems to learn from experience and adjust behavior accordingly. The importance of safety is also acknowledged, as the idea of rogue AI systems is a well-known theme in popular culture. As the description delves further, standard specifications are revealed. Neo is expected to possess a 2 to 4 hour runtime, fueled by an electrical system. Remarkably, it weighs around 30 kilograms or 66 pounds, significantly lighter than the 125-pound Tesla bot designed for heavy lifting. The mobility aspect showcases Neo's walking speed of about 2.5 miles per hour, a common pace for robots. The surprise comes with a run speed of 7.5 miles per hour, 3 times faster than walking. It raises the question of whether Neo can manage this increased speed without losing stability. Another interesting aspect is the robot's carrying capacity, approximately 44 pounds or 20 kilograms, quite impressive considering Neo's weight of 66 pounds. This feature's potential significance lies in its ability to carry substantial loads despite its relatively light build. As we delve deeper into the details, they provide some fundamental insights. They introduce Neo as an innovative bipedal humanoid robot. In simple terms, Neo is designed to move and resemble a human, complete with a head, torso, arms, and legs. This setup allows Neo to interact with the world in a way that feels familiar to us. It can walk, pick up objects, and even convey emotions through facial expressions. Now let's address the burning question. What exactly can Neo do? Given that it's an AI-powered robot, our curiosity about its capabilities is natural. The explanation comes through. Neo is an android with a broad spectrum of skills. It excels in various industrial tasks such as security, logistics, manufacturing, and operating machinery. But that's not all. Neo's potential reaches even further. In the long run, the creators envision Neo as a valuable home assistant, capable of performing chores like cleaning and organizing. Interestingly, Neo could also assist people with mobility challenges, fetching items, and providing companionship. Moreover, Neo's potential extends to the realm of research, contributing to fields like psychology and artificial intelligence. With Neo's continuous improvement, the possibilities for assistance, productivity, and learning are limitless. The concept of how Neo utilizes artificial intelligence becomes the focus of their discussion. Through embodied artificial intelligence, Neo gains a deeper understanding of its surroundings. This is made possible by merging its AI senses with its physical body. This combination empowers Neo to learn and enhance its capabilities over time, becoming smarter and more proficient. This leads to a more natural and intuitive interaction experience with Neo as it adapts to its environment and learns to handle delicate items. This convergence of AI and physicality is indeed intriguing. It's like Neo is gaining a sense of sight as its AI senses merge with its physical form. This alignment is essential because without the ability to perceive its surroundings, how can an AI-driven robot function effectively? Now let's talk about the extraordinary aspect. The creators reveal that Neo's continuous learning and improvement are on the agenda. This means Neo will become progressively smarter and more capable over time. This might not sound particularly groundbreaking at first glance, as most robots are programmed with a fixed set of capabilities. However, there's a shift happening. Some AI systems are now capable of ongoing learning and improvement. This development challenges the traditional notion of static robot abilities. Neo's case is especially intriguing. While there are various techniques for achieving this continuous improvement, the exciting part is seeing whether Neo's learning will be a self-contained system or a software-driven mechanism. This continuous learning aligns with recent AI advancements like the example of DeepMind's robot RoboCat, which mastered a task after seeing just 100 demonstrations. In a field where robots usually require thousands of demonstrations to learn a task, Neo's ability to adapt and grow in this manner stands out. Looking ahead, they mentioned that Neo will be available for pre-orders by the end of 2023. This suggests that the official unveiling is imminent. It's important to note that Neo is set to launch in 2023, which means we'll soon meet our first glimpse of this advanced AI-powered physical robot, backed by OpenAI's cutting-edge software systems. The anticipation builds as we await the debut of a robot that represents a significant leap forward in the integration of large language models and multimodal systems into physical devices. It's truly exciting to witness how this technology is being implemented and how effectively it will be embraced by the world.